Welcome to the Journey Chez Chem. I am so excited today because we're going to do a titration lab. Well, let's do the warm-up questions as quickly as possible so we can move on to the lab. These questions are answered in the discussion portion of the lab. A titration is what we are doing today. We are going to begin our titration today and go on and complete it tomorrow. It is the process used to determine the volume of one solution, which will react with a carefully measured volume of another solution. This is a quantitative determination. We will know the concentration of our acid that we are going to titrate with the unknown base, and we are going to standardize that base or find out what its actual concentration is based on our acid, that we know the specific concentration. And then the indicator is used to determine when the acid has exactly neutralized the base. And because we're using a strong acid and a strong base, this occurs at the pH of 7. And the color changes at the end point. And in this case, we have chosen an indicator that will change at the pH of 7. And that will be when the equivalence point where the hydronium ion is equal to the hydroxide ion. These are very important terms that we will be using in doing this lab. Titrations are found in many, many ways, and this is a very instrumental lab for you to understand because you will see it very often in chemistry these days for a variety of different reasons, and therefore we must have the experience of doing a titration. Plus we love doing lab. And so now that we've gone over the warm-ups, I will introduce some of the equipment in the lab, and then we'll be able to go into the lab. Even though you have some pictures of this equipment, we need to look at it again up close and personal. This tube is called a burette, and it has a stopcock here that controls the amount of the liquid that can come out. It has graduations that are in milliliters, and normally we fill it up to the top to where it measures 0 or actually 50 milliliters. And we will then titrate, we will turn the knob and allow it to go into our solution in an Erlenmeyer flask. We will measure out a specific amount of substance, put it in here, add the indicator, which is critical. The color will not change if I don't have indicator. And then we will swirl while we are allowing it to go drop by drop. And we will look for a faint pink color. Now we're doing this 3 times. So the first time it's okay to do it and get over the amount that we need, too much of it, and it will have a dark pink color. But that will give me an idea of where I need to slow down and get the actual volume. And then the second day we will use the base that we're standardizing today to determine an unknown. I just wanted to show you the equipment. Okay, so I'll see you in the lab. Here we are on day 1 of the titration lab. Now we're very fortunate because we did not have to clean out the burette and make sure that it was ready to go. What would need to be done is that we have a burette brush that would wash the burette, and some people call it a burette, but technically it's a burette. And we would wash it with soap and water and then rinse it with distilled water, and then it would be necessary to use a small amount of our base or whichever liquid that we were putting in the burette to rinse it, because any water that would be left would change the concentration. And we want to make sure that we are determining the concentration of our prepared solution. We are standardizing the base. And what that means is that we are taking an acid of known concentration, 0.1 molar, and using it to determine the volume of the base. And that volume will help us know exactly what the molarity of that base is. And it's all set up, so therefore we go to step 4. We don't need to worry about that. Now the burette is set up so that it begins on the 0, which actually is 50 milliliters in this particular burette. And I like to start at 0 because it makes for simple subtraction to know the milliliters of the base that will be required to neutralize my acid. And what I'm going to do here is I have a graduated cylinder, a small one, and I'm going to measure out exactly 10 milliliters of my acid. Now, we could have some errors in our parallax of looking at the line, and I see that it's above the line, and sometimes professors don't like us to use these eyedroppers to get it exactly on the line, but I'm not returning the material back to my beaker, and I have 10 milliliters of my 0.1 molar acid. And I will put that into my Erlenmeyer flask. Then I'm adding another 10 milliliters of water, and I'm also using it to rinse out the acid, make sure that I'm getting all of the acid into my flask. Now, the amount of water is not critical because it does not change the number of moles. I'm not looking for the concentration, I'm looking for the molarity. The moles, excuse me, not molarity. And the magic ingredient is my phenolphthalein indicator, which I use approximately 3 drops. As long as some of it is in there, that is fine. Now, I'm going to go ahead and titrate. The liquid inside of this burette is called a titrant, and that's what I'm using to determine. I want to know the concentration of this base, and I'm going to go ahead and titrate. Now, the first time I may overshoot it because I'm not quite sure what volume it will require, and I want to keep a pink color for 30 seconds. And I'm going to go ahead and I continue to swirl as it is dropping in there. Then when I see that the pink is lasting longer, I will slow it down to drop by drop. It helps to have a partner because one person can control the stopcock and the other person, and I see I'm getting close. As the pink color lasts longer, then I know that I'm getting close. I'm slowing it down to a drop by drop. And I want to keep that pink color. And it seems I'm very, very close. And I believe we have reached the end point. I want to have the faintest of pink colors. This seems to be a very nice pink. And I will get the volume of my burette. And it is 10.3 milliliters. 10.3 milliliters is the way that I'm reading it. And that's the first time. I will do it 2 more times. Now we have to set up for the second time. I'm going to refill my burette with my unknown concentration of the base. I'm using a funnel in the top, and I'm going to pour it to get back to 0, which allows me to subtract much more easily. And I see that I got a bit too much, but that's okay because I'm going to use an eyedropper. And be careful, some professors don't like us doing that. They would rather us control from the bottom, but I find for my purposes that I use an eyedropper, and I make sure that I do not place materials back into any container whatsoever. It must either go into a waste container or into the sink. not back into my original container. So now I'm back up at 0, which allows for a simple subtraction. I'm going to clean my Erlenmeyer flask of the last solution that we did together. And I rinse it to make sure that there's no acid residue in there. Now I will measure out 10 milliliters again of my acid. Of course, another source of error would be the water that was left behind from the last time in this Erlenmeyer, this graduated cylinder. And I need to remove a little bit here. Oh, it looks like it's on the bottom of the meniscus. And I have my 10 milliliters. Add it to my Erlenmeyer flask. Add 10 milliliters of water. And the magic ingredient, my phenolphthalein indicator. 3 drops. Now I'm going to work it again. Let's see. So we saw that the first time it was a little bit over the 10 milliliters. And therefore I'm going to go to 10, not worry too much about it. I'm going to go close to the 10 in any case. The pink color is lasting longer. I know that I'm getting close. Now I will go to drop by drop. I believe I've reached my end point. Oh, I'm so close. One more drop here. And I have a beautiful pink color here on my Erlenmeyer flask. Beautiful pink color. Now I'm going to read my burette, and it is 10.3 milliliters again. Now this time I'm going to go ahead and prepare the burette, rinse out my flask, and be ready to go. I'll be right back. Here we are for the final trial of standardizing my base. I have gone ahead and set up the burette at 0, and I have my Erlenmeyer flask with my 10 milliliters of 0.1 molar acid, hydrochloric acid, 10 milliliters of distilled water, and my drops of the magic ingredient of phenolphthalein. Well, I know that it's going to occur around 10, so I'm going to go ahead and titrate here and go on down to 10 milliliters. Whoop! Now I'm going to go drop by drop. I could tell that the pink was staying longer. I'm going to go drop by drop. It's very nerve-wracking. And there we go. It is a very nice pink color. It must stay for 30 seconds. And there we go. We have reached a beautiful pink color. That is our end point. My volume is 10.9 milliliters. 10.9 milliliters is my final volume. Now, we have the choices of choosing the best pink color or an average. I prefer to use an average because our third volume was a bit different. And I'm a little concerned about that, so I think the best thing to do would be to average those values. Remember, this is experimental data, and you try to do the best you can and make the most of it. So we're going to go ahead and use the average of these 3 volumes to determine the concentration of our base. Well, I can't wait to see tomorrow. We're going to determine the molecular mass of an unknown acid. And that's something to look forward to, another day of lab and determining an unknown. So I can't wait to see you then. Bye.